Problem 3 and 4 are about rectangles, so we saw some of these before. So this is really just a matter of being able to draw a decent picture. A rectangle is 3 meters shorter than twice its width, so if we're not sure what to do, we could just make a guess here. Let me just pick a width, so I'll say 10 is my width. I'll use W for that. So if the length is 3 meters shorter than twice the width would be 20, so 17 is twice the width minus 3. So the area in this case is going to be 17 times 10, or 170 meters squared. You can see that's not what it's supposed to be, right? We want the actual area to be 629, so that tells me that my guess is wrong. It's not 10 meters wide, but hopefully by doing that, I now have an idea of how to do the general problem. So if instead of the width being 10, if I just call the width W, then the length is going to be taking twice the width minus 3. That's exactly how I got the 17 here. I doubled my width and subtracted 3. So if I call the width W, doubling the width and subtracting 3 is that. And so then my area function would be just the product of the two dimensions. So here it was 17 times 10, because this was 17, this was 10. So here it's going to be this dimension times this dimension. So this is an expression for the area of the rectangle. We're told to check that against 629 meters squared. That's how we knew that this one wasn't right. We compared an answer to 629 and it wasn't correct. So my wish then is to have this 2W. I'll go ahead and multiply this out. So I'm just distributing here. So I'll multiply out the 2W squared minus 3W. And I'd like that to equal 629. So the problem really comes down to solving this equation. So I see I'm kind of out of room here, so I'll just work down the page, and then I'll start with the blank slate again for problem 4. So just kind of ignore the fact that I'm in the middle of problem 4 now. To solve this equation, we know that we want to get everything on one side, so that this thing is equal to 0, and then our goal is to factor it. And of course, if you don't have the stomach for factoring it because the numbers are large, then you can always just use the quadratic formula. I don't think this is terribly bad, but I do need to understand how 629 factors. And that's the worst part of this, because it doesn't have very nice factors. If you do a little bit of exploring, you'd find out that 629 is actually 17 times 37, so it's not something that you would guess easily. It's not got little small factors, but because of that, that tells us that these two numbers, because it's very limited, it means these two numbers for the last times the last need to be 17 and 37. So a 17 here will give me an outer terms multiplying together to be 34, and the 37 here will make my inner terms multiply to be 37. So I have an outer of 34 and an inner of 37, and so those are 3 apart. And so as long as I have a negative here and a positive here, then I will get the right factorization. So this would mean that W is 37 over 2. Oops. (37/2), or W is negative 17. And obviously negative 17 is not a very sensible answer for a width of something. So because of the fact that W stands for the width of a rectangle, W really can't be negative 17. So my answer is, back in my original rectangle, the one that I have up here, that my width should be 37 halves, so that's like 18 and a half, and my my length, then the other dimension, remember, comes from doubling the width and subtracting 3. So if I double 37 halves, I get 37. Subtract 3, you get 34. So these are the dimensions of the rectangle that has 629 meters squared and has the property that the length is 3 less than twice the width. I'll skip the one with the pen. It's just like the one that was on the slides. So if you can follow the picture on the slides, you should be able to do that one okay. These other two problems about quadratics having a custom look about them is just based on forms. Remember, we said there were 3 different forms for quadratics, and if you happen to know the x-intercepts like we do in this problem, then we know that the zeros of the function and the factors of the polynomial are related to each other. So telling me that you have x-intercepts at 5 and negative 5 means that in order to put 5 in for x and have this thing return 0, that means that there's a factor of x minus 5. Putting 5 in for x makes this factor 0, so the whole thing is 0. Similarly, putting negative 5 in for x would make this factor 0 and make the whole thing 0. So the only other parameter in this thing is that you could have a number out in front. So your function has to look like possibly some number in front. Could be 1 times x minus 5 times x plus 5. Just by having those factors, we are sure that the x-intercepts will be those two things. So we have a piece of information we haven't used yet, namely that this is also supposed to go through 0, 10, and we have one parameter that we don't know yet. And so we're going to use the extra information we have about the point to find the missing information about the letter out in front. So to do that, I just compare the two things. I can say f of 0 is supposed to be 10, right? So this is given to me. And I also know that f of 0 is a times negative 5 times positive 5 from the formula above. Right? That's just putting 0 in for x in this formula. So f of 0, negative 5 times 5 is negative 25a. So f of 0 is negative 25a, but f of 0 is supposed to be 10. So that tells me that negative 25a is equal to 10, and so a is negative 2/5. So my formula then is this f of x that I wrote down, get rid of those pieces, but instead of having the a in front, I'll have negative 2/5. This next problem is the same thing. We're given two x-intercepts, so I'll call this one g, but it'll be the same thing. There's some number times the fact that I know the x-intercepts means that I know the factorization. A quadratic function that has x-intercepts at 5 and 0 has to have x minus 5 as a factor and x minus 1 as a factor. The only thing that's mysterious is what this number is out front. And so we're going to use this extra piece of information we have to figure out the extra thing we want to know. So we're given that we want g of 0 to be 10. Right, that's what this piece of information tells us. We're given, the formula tells us that g of 0 is a times negative 5 times negative 1. So that's what I get from my formula. And so that's 5 times a. So the fact that those two things have to be equal means that 5 times a needs to be 10, so a will be 2. So if I go back to my original form for g, I want that erased. Oops. Well, can't erase it. Okay, fine. So my final answer, then I'll just squeeze it down here, is g of x equals 2 times x minus 5 times x minus 1. And don't forget, you can check these answers. It's really, really easy to check that all three of these points do what they're supposed to do by just putting in the x coordinate and checking the y coordinate.